It was January 8th, 2009. The day started as it always did for Brooke Greenberg. Her mother, Melanie, woke her with a soft kiss and a gentle whisper, "Good morning, sunshine," before carefully lifting Brooke out of her crib. Afterwards, Brooke ate her favorite breakfast of scrambled eggs and then headed off to school. Brooke's favorite part of the school day was always story time. Her eyes would light up at the very mention of princesses, enchanted castles, and faraway adventures. But cognitively, she was still having trouble learning her colors and the alphabet. Despite these challenges, Brooke never stopped smiling, and she was especially happy today. It was her birthday. When Brooke got home from school, her three sisters helped her get ready for the party. They shuffled through her dresser drawers, searching for the perfect dress. They finally chose one, a tiny garment decorated with daisies, a dress that could have easily fit a child's doll. As they finished getting her ready, their mother called from the kitchen. The girls came racing down the stairs, carefully carrying the 15-pound Brooke in their arms. Her sisters gently buckled her into her high chair, while their mother brought a chocolate cake from the fridge, its surface blazing with candles. Then, the whole family gathered around and sang Happy Birthday as Brooke clapped her small hands along with the tune. When it was time, Brooke's sisters helped her make a wish and blow out the candles. On this day, Brooke Greenberg was turning 16 years old. When our bodies fail to follow the fundamental rules of life, we trust our doctors to find the reason why. But medicine isn't always an exact science. Sometimes, it's a profound guessing game, with the very nature of existence at stake. Welcome to Medical Obscura. In this investigation, we explore the extraordinary case of Brooke Greenberg, the girl who didn't age. Brooke was one of only a handful of people in the world ever documented with a condition so rare it was for years known only as Syndrome X. This mysterious genetic disorder appears to cause a severe, global developmental delay, one that has kept patients looking and behaving like toddlers, even as the years and decades continue to pass. The condition also leads to a host of life-threatening internal deformities, making it difficult for them to breathe and eat. In this episode, we will uncover Brooke's incredible journey and the scientific search for others like her. We will also learn how this one unique syndrome could, paradoxically, hold the key to slowing down or even halting everyone's aging process. For thousands of years, humans have searched for the key to eternal youth. Ancient alchemists conjured dangerous elixirs of mercury and lead, believing these toxic metals would lead to eternal life. Most of the time, they did just the opposite. Centuries later, people turned to safer, if less effective, remedies. Botox injections to smooth out wrinkles, acai berries to fend off toxins. But science still had not discovered a way to fundamentally stop or slow the process of human aging. That is, until researchers met a young girl named Brooke Greenberg. But Brooke's story begins in the early 1990s, when Melanie and Howard Greenberg's life looked just like that of any other typical American family. The couple lived in a quiet, pleasant neighborhood in the suburbs of Baltimore, Maryland. Howard had a secure job as a salesman, and the couple was busy and happy, raising their two healthy young daughters, Emily and Caitlin. When the Greenbergs became pregnant for a third time in 1992, they had every reason to believe that the pregnancy would go smoothly. But they were in for a huge and worrying surprise. After her first trimester, Melanie knew, instinctively, that something was off. Early in the second trimester of a healthy pregnancy, a baby is meant to grow at a rate of about 1 to 2 ounces per week. But Melanie's baby was growing much less consistently. Her own weight gain, a key indicator, was not what it should have been. As this serious issue continued into Melanie's third trimester, doctors began to warn the expectant mother that her baby's extremely low weight could lead to a host of dangerous problems after birth. They explained that if the baby's lungs didn't fully develop, she could have severe trouble breathing outside the womb. Furthermore, the infant's immune system would almost certainly be weakened, making it much harder for her to fight off common and potentially deadly infections like pneumonia. This news deeply frustrated Melanie. She was doing everything in her power to ensure her baby was healthy. She maintained a perfectly healthy lifestyle and a meticulously nutritious diet. And still, her baby was barely growing. Ultrasound technology was far less advanced in the early 1990s, so doctors could only speculate about what was going wrong. Melanie's obstetrician theorized that her baby might not be receiving enough vital nutrients through the umbilical cord. Based on this, he delivered a stark and terrifying warning. The infant might not live long enough to even see her due date. Faced with this grim prognosis, Melanie opted for an early C-section at around 36 weeks, approximately 3 weeks before her full term. By 36 weeks, an average baby weighs around 5.5 pounds. But when Brooke Greenberg was born on January 8, 1993, she weighed only 4 pounds. And according to her doctors, she had other, immediate, and unique problems. She came out of the womb with an extreme anterior hip dislocation, a condition so severe that one of her tiny legs was bent completely upward toward her head. It looked as though she had been folded in half. This type of hip dysplasia occurs in about 1 out of every 1,000 births, when the hip joint fails to form properly. Brooke soon underwent surgery to correct the issue and was kept in the neonatal intensive care unit to recover. But even with the operation, doctors warned her parents that she could have a very hard time learning to walk in the future. The first 5 weeks of Brooke's life were spent in the hospital, and it was there that doctors discovered a few other unusual things about her, like the abnormal shape of her ears and her unusually wide-set eyes. Facial abnormalities like these can often be telltale signs of a genetic disorder, a disease caused by a mutation in a person's DNA. DNA works like a tiny, complex blueprint for constructing a human being, but it isn't infallible. A person's DNA can acquire mutations through various mechanisms, sometimes passed down from a parent, and other times occurring spontaneously as the result of environmental factors. In Brooke's case, her combination of low birth weight and facial abnormalities led doctors to begin looking into some of the more common genetic disorders, like Down syndrome or Noonan syndrome. Down syndrome, for instance, is the result of a baby being born with an extra copy of chromosome 21. This genetic anomaly can cause facial abnormalities similar to Brooke's, as well as significant developmental and speech delays down the road. Noonan syndrome is less well known, but it also causes a characteristically slower rate of growth and can lead to heart problems. At first, based on her physical signs, doctors strongly suspected that Brooke might have one of these two conditions. So they ran genetic tests for both. But both tests came back completely negative. In fact, Brooke's DNA showed no signs of any known genetic mutation at all. Her doctors were utterly dumbfounded. By the time the initial 5 weeks in the neonatal unit were over, Brooke was showing some positive signs of improvement. She had recovered well from her hip surgery, and she was able to drink from a bottle. With no other immediate leads to investigate, the doctors agreed to let Brooke's worried parents finally take her home. But her health did not remain stable for long. Brooke's mysterious lack of physical development also meant she had a severely weakened immune system, which made her dangerously prone to infection. And as she passed the 4-month-old mark, she began to experience frequent and serious respiratory issues. This in itself was worrisome for the Greenbergs, but they became even more disconcerted when their tiny daughter began having seizures. While certain types of seizures can be common in young children, they are usually brief and triggered by something simple like a fever. But they can also be indicative of something far more serious, like a brain tumor or epilepsy. Typically, a seizure lasts for under 2 minutes, but at 4 years old, Brooke experienced a single, continuous seizure that lasted for a terrifying 45 minutes. Most of the doctors who treated her had never seen anything like it. They immediately put Brooke through an MRI machine, searching for a tumor or signs of epilepsy that could explain the episode. But the scans showed no signs of either. Ultimately, the doctors could only conclude that Brooke's brain was still severely underdeveloped and that this may have contributed to the prolonged seizure. Miraculously, a follow-up scan showed that the extended seizure had caused no permanent brain damage. At the same time, Brooke was having extreme trouble keeping her meals down. In a dangerous development, food was frequently going into her lungs rather than her stomach. This put her at constant risk for pneumonia. But even more troubling, without being able to consume food safely, Brooke was unable to get the vital nutrients her small body desperately needed. As a result, she had to have a feeding tube surgically inserted so that nutrients could be delivered directly into her stomach. To the Greenbergs, it felt like their daughter was facing a new, life-threatening medical problem every single day. They went from doctor to doctor, desperately looking for answers that no one could provide. And then, things got even worse. Shortly after her massive seizure, Brooke suffered from a stroke. Strokes are incredibly rare in children, affecting only about 12 out of every 100,000 kids. Like a seizure, a stroke is the result of abnormal brain activity. But whereas a seizure is caused by a surge of electricity, a stroke is caused by an interruption of blood flow to the brain, and it can easily lead to permanent, catastrophic brain damage. And yet, just as she did following the seizure, Brooke recovered from her stroke with no apparent long-term problems. It appeared that no matter what her mysterious condition threw at her, Brooke always, somehow, came out the other side, completely unscathed. Her doctors were astounded. Each one of these medical events, the seizure, the stroke, would have been difficult for a healthy adult to recover from, let alone someone as small and frail as Brooke. But the most mysterious of all of Brooke's ailments happened later that year, just before she turned 5. One morning, the Greenbergs noticed that she had fallen into a deep, lethargic state. It was a coma-like slumber, and they could not wake her. Brooke's parents rushed her back to the hospital. An emergency MRI revealed the cause. A giant, malignant tumor had appeared on her brain. Because of its massive size and its precarious position, the doctors declared it completely inoperable. They delivered the devastating news to the Greenberg family. Brooke had only 48 hours left to live. The family was heartbroken, but they felt some small solace in knowing that their daughter wasn't in any pain. They gathered to prepare their goodbyes. They even bought a tiny casket. But the 48 hours came and went. Brooke remained in her deep, sleep-like state for a full 14 days. The whole time, her family stayed by her side, clinging to her every breath, wondering if it would be her last. And then, on the final day, Brooke simply woke up. She was her usual, smiling self. The Greenbergs were overcome with joy, and once again, Brooke's doctors were utterly gobsmacked, especially when she underwent another MRI scan. By all appearances, the massive, inoperable tumor in her brain had completely disappeared. It was, by any definition, a miracle. Brooke's doctors pored over her past scans, wondering if they had misread something. But there it was, in stark black and white, the image of the now missing brain mass. The medical professionals struggled to find the words to even describe what had happened, and the puzzle didn't end there. Immediately following this coma, Brooke's grueling series of life-threatening medical emergencies simply stopped. Her health became relatively stable and manageable. Melanie and Howard were deeply grateful, but they were also disappointed when the doctors, with no answers to give, told them there was nothing else they could do for Brooke. After everything she had been through, her underlying condition was still a complete mystery, and the Greenbergs were more determined than ever to solve it. She had suffered from stomach ulcers, massive seizures, chronic respiratory issues, and a laundry list of other terrifying health problems. But the most shocking anomaly of all had been the apparent brain mass that had completely and inexplicably disappeared, leaving Brooke's health, for the first time in her life, relatively stable. But she still wasn't growing. Physically and developmentally, it appeared she would remain a baby forever. And what's more, her doctors still could not identify her underlying condition. At 5 years old, Brooke weighed around 13 pounds and was still unable to speak. But with her newfound stable health, she was finally able to attend a special needs school. Using a customized rolling walker, Brooke got her very first taste of independence. Meanwhile, her parents, Howard and Melanie, continued their relentless search for answers. At the very least, they hoped to find a way to keep Brooke strong and healthy. A nutritionist prescribed high-calorie supplements to try and increase her weight, but after weeks of taking them, nothing had changed. Their next stop was a trip to an endocrinologist, a doctor who specializes in the body's complex hormonal systems.
Normally, a part of the pituitary gland at the base of the brain releases a growth hormone called somatotropin. This hormone acts like a messenger, telling the body's organs, bones, and tissues that it's time to grow.
When the pituitary gland doesn't work properly, as the doctors suspected might be the case with Brooke, growth is inhibited. So Brooke's endocrinologist gave her a course of growth hormone injections, hoping to make up for any potential issues. But even that didn't work. Next, Brooke was tested for another rare genetic disorder called Werner syndrome. This condition is caused by a mutated gene that affects DNA repair. Individuals with Werner syndrome age differently than Brooke. Their growth is often delayed during puberty, and then their internal clock seems to rapidly speed up in their 20s. Still, Brooke's doctors felt it was worth a shot. Perhaps she had a rare, unknown form of the disease. But Brooke tested negative for Werner syndrome. And just like before, no other genetic abnormalities were showing up on any of her tests. It truly seemed like Brooke was the only person in the entire world with this specific, mysterious condition. And as time went on, her longtime pediatrician, a Dr. Lawrence Pakula, finally gave her unknown affliction a name. He dubbed it simply Syndrome X. Through it all, Brooke's father, Howard, remained steadfastly hopeful. He came to believe that if they could just find the root cause of Syndrome X, then all of his daughter's suffering wouldn't have been in vain. Perhaps, he thought, her unique and mysterious condition could have a larger, positive impact on the world. Howard even remarked to a journalist, "What if Brooke holds the secret to aging? We'd like to find out. We'd like to help people." As Brooke grew older, media outlets from all over the world began taking an interest in her extraordinary case. And this media attention led to a major breakthrough in 2005 when the American television show Dateline filmed a segment about Brooke. When the episode aired, a woman in Tampa, Florida, called her husband into the living room. She knew he would find this kind of story deeply intriguing. Her husband was Dr. Richard Walker, an endocrinologist at the University of South Florida College of Medicine. He had entered his profession, in part, because he was haunted by the memory of his own grandparents' physical and psychological deterioration in their final years. He hoped his work could one day spare other people that same end-of-life suffering. Dr. Walker was especially interested in uncovering the fundamental mechanisms behind the process of aging. He wanted to know what, on a cellular level, led us to develop conditions like arthritis or Alzheimer's disease. If he could pinpoint this mechanism, he believed, then maybe he could find a way to slow down aging for everyone. When Dr. Walker saw Brooke's case on television, he was electrified. He immediately contacted the Greenberg family and asked if he could study their daughter. He believed that Brooke's unique DNA might hold the very answers to the prevention, or at least the mitigation, of the aging process itself. By the time he met Brooke in 2005, she was 12 years old. She measured just 27 inches tall and weighed only 13 pounds, about the size of a healthy one-year-old child. But the rest of her body was even more strangely out of sync. A dental exam showed that Brooke's teeth resembled those of an 8-year-old. X-rays of her bones showed they had the density of a 10-year-old. Meanwhile, her hair and nails were growing at a completely normal rate. And yet, Cognitively, her mental age was estimated to be equivalent to that of an 8-month-old infant. Brooke could barely walk, talk, or feed herself. She primarily communicated through the basic emotional expressions of an infant, laughing, crying, and flapping her hands. Dr. Walker was informed by the Greenbergs that all of their past dietary and hormonal treatments hadn't helped in the slightest, and that every known genetic disorder had been conclusively ruled out by previous tests. But that didn't necessarily mean Brooke's problem wasn't genetic. It just meant, perhaps, that those previous tests had missed something entirely new, something never before seen by science. We can all recognize the common, outward manifestations of age: gray hair, wrinkles, the gradual loss of hearing and sight. But what actually causes these things to happen on a fundamental, biological level? The answer lies deep within our dividing cells. As we've mentioned before, DNA works by replicating itself. But it's also involved in the crucial process that helps all living organisms repair themselves. Our cells are constantly dividing to replace old, dead, or damaged ones. The human body contains an estimated 30 to 40 trillion cells, and this massive number needs to be maintained in a healthy adult, meaning that billions of new cells must be created every single day. However, as time goes on and a person ages, more and more mistakes are inevitably made during this constant replication process. And the body's typical repair mechanisms, over time, lose some of their effectiveness. You can think of it like an old photocopy machine, one that's slowly running out of ink as it churns out each new, slightly degraded page. This is, on a cellular level, why our bodies form wrinkles as we get older. At first, Dr. Walker's primary research goal was to find out exactly why our cells deteriorate in this way. But when he met Brooke, he was faced with a more immediate and far more paradoxical concern. He wanted to know what biological mechanism was keeping Brooke's body from changing and developing in all the normal, external ways, yet, at the same time, seemed to be making her cells break down and age rapidly on the inside. Dr. Walker consulted with his colleague, Dr. Maxine Sutcliffe, a geneticist at Johns Hopkins All Children's Hospital in Florida. Dr. Sutcliffe decided the best way to approach this strange question was by examining the length of Brooke's telomeres. These are the small protective caps on the very end of our chromosomes, which you can think of like the little plastic tips on the end of a shoelace. They are there to protect the DNA from fraying and damage. Telomeres are also a very useful tool for estimating a person's biological age because they naturally get shorter the older we get. When Dr. Sutcliffe examined Brooke's DNA, she found that her telomeres were, in fact, much shorter than those of a healthy teenage girl. This indicated that, on a cellular level, Brooke was indeed aging more quickly than normal. Right away, this seemed completely counterintuitive. Why were Brooke's telomeres looking so old when her body still looked like that of a toddler? That single, baffling question led Dr. Walker and Sutcliffe to another shocking realization. Brooke's body wasn't growing, or failing to grow, as a single, cohesive unit. Instead, it was behaving like a collection of randomized, uncoordinated pieces.
Dr. Walker dubbed this strange phenomenon developmental disorganization. He explained that in an average person, complex actions like eating require multiple, separate systems to work together in perfect coordination. But in Brooke's case, her various biological systems were not working in concert with each other. This lack of coordination, he believed, had likely led to many of the severe medical ailments she had experienced since birth. And Dr. Walker didn't think this was happening by some random fluke of nature. He became convinced that it had to stem from some sort of never-before-seen genetic mutation. But first, he knew he needed to find the specific mutation. He needed to know which one of the 3 billion DNA base pairs in Brooke's entire genome was the culprit, and whether or not it could be fixed. As far as Dr. Walker could tell, Brooke was the only person in the entire world with this unique condition. This meant he had no other cases to compare her to, a massive roadblock for genetic research. If he was ever going to get to the bottom of it, he realized he would have to do something monumental. He would need to sequence Brooke's entire genome. In other words, he would need to read and analyze all 3 billion letters of her genetic code, a process that, at the time, was incredibly difficult and expensive. Unfortunately, Dr. Walker never got the chance to make this happen. In 2009, when Brooke was 16 years old, her family abruptly and unexpectedly broke all ties with the researcher. No one ever offered a concrete, public explanation as to why. In any case, Dr. Walker was forced to come to terms with the devastating idea that he might never know the real cause of Brooke's disorder, and that he might never know if her unique DNA truly held the answers to slowing down the aging process. And then, something completely unexpected happened. Also in 2009, a television documentary about Brooke Greenberg aired on the network TLC. Millions of viewers were fascinated and deeply moved by Brooke's incredible story, and some could relate to it on a deeply personal level. Like the Greenbergs, there were other families out there, scattered across the country, also searching for answers for their own unique children. Many of them, after finding out that he had once cared for Brooke, got in touch with Dr. Walker. Suddenly, his search for the key to eternal youth was back on track. A woman named Mary Margaret Williams from Billings, Montana, contacted Dr. Walker about her 5-year-old daughter, Gabby. Gabby had stopped growing when she was 3 years old, so her experience wasn't exactly identical to Brooke's, who had stopped growing much earlier. But in many other ways, their stories were strikingly similar. Like Brooke, Gabby had suffered from a long and disconnected series of severe illnesses. She had trouble swallowing, she had chronic respiratory infections, and she, too, required a feeding tube to get nutrients. And, most importantly, she simply wasn't growing any bigger. Dr. Walker was convinced. He had finally found another case just like Brooke's. Their symptoms lined up almost perfectly. So he arranged to test the DNA of the entire Williams family, hoping to pick up his vital research right where he had left off.
While Dr. Walker's initial findings did identify several unusual mutations in Gabby's DNA, there wasn't a single one that clearly explained her condition. Despite these inconclusive results, he remained hopeful that she and Brooke were biologically similar. After all, Dr. Walker believed that Gabby was, without a doubt, another patient with Syndrome X. Then, in 2013, Walker and his team learned to utilize a new and powerful technique that could help his research. It was called the epigenetic clock. The epigenetic clock is a sophisticated biological test that can measure a person's cellular age by examining their DNA methylation levels. DNA methylation is a natural process where small chemical compounds called methyl groups attach themselves to strands of our DNA. These compounds act like tiny switches on the DNA, turning a person's genetic activity on or off. For this reason, DNA methylation is sometimes referred to as a cellular switch, and overall, it helps the body's complex systems run smoothly. For example, it can turn on the genetic activity needed to guide fetal development, or it can turn off harmful genetic activity that might be dangerous. Like most things at a genetic level, methylation can be triggered by external factors, and a lack of it can lead to negative effects. But in Dr. Walker's research, the epigenetic clock was a tool. It could help him figure out if different parts of Gabby's body were, in fact, aging at different, independent rates. Specifically, he began to compare the epigenetic, or cellular age of Gabby's blood tissue to her actual chronological age. His team's analysis determined that their disorder, surprisingly, did not cause these two ages to differ in a significant way. Therefore, their unique aging process was likely not arrested in all tissues, adding another layer to the puzzle. In January of 2011, TLC released another documentary, this one about Gabby Williams. This renewed the public's interest in Syndrome X, and eventually it caused 3 more families to approach Dr. Walker. Like Gabby, all 3 of these new patients were girls who had stopped growing around the age of 3 or 4. Their names were Lila, Alyssa, and Jennifer. Each of their families consulted with Dr. Walker and his colleague, Dr. Radoje Drimanak. And in 2015, they all agreed to participate in a new, comprehensive genetic study. This state-of-the-art program would sequence the entire genomes of the girls and their families to search for the exact damaged gene and to finally find out if it had been inherited. With 3 billion DNA base pairs per individual genome, it was a monumental task. Even Dr. Walker admitted, this search is comparable to finding one spelling mistake in a whole library full of books. But the study went smoothly. Blood samples were sent to a leading medical tech company in San Jose, California. The professionals there analyzed gene after gene, comparing them with a level of precision that was previously impossible. 4 weeks later, Dr. Walker and Dr. Drimanak finally got some answers. The results were a stunning breakthrough. They found that all 3 girls shared the exact same 5 damaged genes. Walker and Drimanak also discovered that this specific, shared mutation kept the girls' bodies from properly synthesizing certain proteins. Proteins are the fundamental building blocks of life, They do most of the essential work in our cells, helping us to function and grow. They also regulate all of our body's tissues and organs. So, without the proper proteins, normal growth is impossible. In the case of these three girls, this genetic malfunction had prevented their bodies from developing. It was also, the doctors realized, the root cause of all their complex health issues. Their organs simply couldn't synthesize the specific proteins they needed to function and survive. And interestingly, these genetic errors were not found in any of the girls' parents. This meant that they were de novo, or first-time mutations. It proved that the disorder wasn't being passed down from the parents. Rather, it was something that had mutated spontaneously and, tragically, inside each of the individual patients. Dr. Walker and Dr. Dremenak were thrilled with their discovery, and they were finally able to give Syndrome X a new, more accurate scientific name. They called it Neotenic Complex Syndrome. Neotenic to describe the childlike condition present in the girls, and complex to refer to the subsequent clinical problems resulting from their syndrome, like the digestive, respiratory, and cognitive issues. It also didn't escape the doctor's notice that each of their identified patients, Brooke, Gabby, Lila, Alyssa, and Jennifer, were all female. But whether or not this extremely rare syndrome is exclusive to women remains to be seen. For Brooke Greenberg, the girl who started it all, the diagnosis came too late. Brooke died in 2013, 2 years prior to this groundbreaking discovery. She was 20 years old, and she weighed only 17 pounds. Her official cause of death was bronchomalacia, a condition caused by weak cartilage in her bronchial tubes, which ultimately made it impossible for her to breathe. She never lived to get the advanced genetic testing that could have definitively proven whether or not she had neotenic complex syndrome. But her doctors are as certain as they can be that she, along with Lila, Alyssa, and Jennifer, all possessed this same unique mutation. Whether or not Gabby had the condition remains, officially, unknown. But given her striking similarities to the other girls, it seems overwhelmingly likely. Brooke Greenberg's incredible story made it possible for other families, lost and without answers, to find each other. And it made it possible for Drs. Walker and Dremenak to finally discover and name a new syndrome. Meanwhile, geneticists are hoping to solve the remaining mysteries of this strange disease. Dr. Walker believes that further advancements in technology will lead not only to earlier diagnoses, but also to the development of new treatments and medications. And now that doctors have a better understanding of the mechanisms of genetic aging, we could be one step closer to finding answers for age-related diseases like Parkinson's and Alzheimer's. When it comes to this one mysterious syndrome, and the handful of extraordinary children who live with it, the mythical fountain of youth might not be so mythical after all. Their unique biology may truly hold the secret to a longer and healthier life for us all. The story of the girl who didn't age is just one file from our archives. There are countless others, each a testament to the enduring mystery of the human body and the strange paths medicine has walked. If you wish to uncover more of these forgotten stories, subscribe to Medical Obscura and press the notification bell.
Join us as we continue to explore the shadows where science and the unexplained collide. We have many more cases to open.